Okay, so we are looking at 10.1, which is called Developing Formulas for Triangles and Quadrilaterals. And let's start with the area addition postulate. The area addition postulate says that the area of a region is equal to the sum of the area of its non-overlapping parts. So for example, if I have a shape like this, for example, nice house maybe with a little walkway here, something like that. If I want to know the area of the region here, I can just add the individual areas together. I could find the area of the triangle, I could find the area of the square, I could find the area of the rectangle and add them all together. Are they going to announce it, or are you just supposed to go? Okay, we'll see you guys. I'm recording. I'll put this lesson on. Make sure you got that worksheet with you. That's part of your homework. Okay, so again, if you would want to find the area of this region, you could add the individual areas together. All right, so that is going to be helpful for us in this idea. Remember that the formula for the area of a rectangle is base times height, but what about the formula for the area of a parallelogram? Well, if I have a parallelogram and I want to find the area of this parallelogram, I could say, you know what, let me make it into a rectangle by taking this triangular piece right here, cutting it off the parallelogram and putting it over here. Then what shape would I have if this piece is now gone? Now I got a rectangle, and so the area is still going to be base times height. The base of the original parallelogram times the height of the parallelogram is going to be our area. So that gives us the area of a parallelogram, which you can put on your tool belt, and I would also like you to add it to the formula sheet that I gave you. So right where it says formula for the area of a parallelogram, you can say area equals base times height for a parallelogram. Everybody see where I'm at on the worksheet? Yeah, don't worry about that for right now. You don't need to put anything there.
Morning. At this time, we ask that the students going on the Honors English 10 field trip please go to the cafeteria now.
Okay, so let's say we wanted to find the area of this parallelogram. In this case, the parallelogram, well, let's see what we know. We know that this is 6 inches here. We know that this side here is 5 inches. So is it just 6 times 5? Is that the area of the parallelogram? No, we need to know the height. We're not given the height, but we are told that this side right here is 3. All right, if this length here is 3, can we find this h here? Because this is going to be the height of our parallelogram. Hint, we better focus in on this right triangle right here. This right triangle had this side as 3, this side as 5, and we're calling this side h. How do we find h in this case? If you have a right triangle and you know 2 of the sides, you can use the theorem to find the third side. It's not necessarily 30, 60, 90 triangle, Colin. All right, Pythagorean theorem. So we want to say a squared plus b squared equals c squared, where the two, stop the hate, no hate zone. So what are we going to plug in for a, b, and c? Amanda? Pardon me? 5 squared. If 5 is the what? Is 5 going to be the a, the b, or the c? It's our hypotenuse. It's across from the right angle, so it goes by itself. It's the c. So we want 5 squared over here. We'll say 3 squared plus h squared over here. So what is h going to be? Give you 30 seconds to calculate that. All right, what'd you get for this, Colin? Really? What's 3 squared?
9.
So I got 9 plus h squared equals, what's 5 squared? So what do I do next? Find h squared. I'm going to do what?
I've never been good at this.
This is algebra 1 right here. What do I do to get h squared?
5 minus 9. Sorry.
Thank you. I'm subtracting 9 from both sides, so I get h squared equals 16. So h is equal to what?
16. Oh,
Take the square root. So h is equal to 4. So that tells us that our height is equal to 4. So now, to wrap this problem up, what is the area of the parallelogram now that we know that the height is 4? Emily. 24 inches. Everybody agree? 24 square inches? Are we okay with this? All right. And let's find the area of this parallelogram here.
I'm just saying, forget it.
You want me to pick a different color?
No, like the shape. I mean, the colors. I mean,
There. I'll leave it like that. Okay. So there's the parallelogram, and I just thought it was more clear than with that. All right. So anywho, I tried my best to get this parallelogram to fit over here. So what do I know about this parallelogram? This side is 11, and this side is 34. And we're trying to find the area, and we are told that if we go from this corner straight out to above this corner, that is 30 millimeters. All right, so if that's the case, then how are we going to find the area here of the parallelogram? We're trying to find this height first, right? Don't we need to know this height? Because that's going to be the height of our parallelogram. And so in order to find that, we have h, 30, and what's this length here? 34. So again, you got a triangle now that looks like this, h, 30, 34. You get the idea of what you're going to do? How are you going to write this? How are you going to write an equation to find this? Aaron.
30 squared plus h squared equals 34.
All right, 30 squared plus h squared equals 34 squared, because our a squared plus b squared equals c squared, Pythagorean theorem. So you're working on this. Lauren, what do we do first? What's 30 squared? 900. And what is 34 squared? 1156? 1156. And we subtract 900 from both sides. And we get h squared equaling what? 256. And the square root of that is what? All right, so h equals 16. If that is the case, then this is 16. So the area of the parallelogram is going to be what? Emily? Emily, you're in there twice. Aren't you lucky? Seriously. If we want to find the area of a parallelogram, it's base times height. What are we calling the base? 11 is the base. Here's the base is 11, or it's up here. And then the height we said was what? 16. So we need 11 times 16, which is what? All right, 176. And we would say square millimeters. Are we okay with this? Okay. I'm skipping that one. Skipping that one. Okay, let's get to the area formula for triangles and trapezoids. All right, so here's what I want you to notice. If we want to find the area of a triangle, and I know you all know the formula, half the base times the height, right? Or base times height divided by 2. But why is that the case? Because if we have this triangle right here, and I want to find the area of that, let's say I have that and I rotate it and I slide it right next. Now, what shape did I make by putting these two triangles together? A parallelogram. And we already know the area of a parallelogram is base times height. Agreed? So, but if we only want the area of one of these triangles, not both, we would have to divide by 2. Does that make sense? So that's why the area formula for a triangle is half the base times the height. Did you get that written down on your formula sheet? And it's on your tool belt. Okay, so what about the area of a trapezoid? By the way, what's our definition of a trapezoid? A trapezoid is a quadrilateral with blank, 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 blank. Fill in the blank. What's special about a quadrilateral that we're going to call a trapezoid? 2 pairs of parallel sides? Do we agree? Jacob's just guessing. Do you agree with that? Does a trapezoid have 2 pairs of parallel sides?
Yes.
No. I think that only the bases are parallel. Wouldn't you agree? This base parallel to this. Are these 2 sides here parallel to each other?
No.
No. So a trapezoid has only 1 pair of parallel sides. Here?
No, the top one.
This one?
Yeah.
Well, that's not a trapezoid. Here's our trapezoid. Okay, so again, let's focus on this. If I have this trapezoid here, and I want to find the area of that, let's say I make a copy of that. All right, so that's this guy right here, but I want to find the area, so I'm going to rotate this, and I'm going to put it right next to the original. So if I put these, stop that. If I put these 2 together, then what shape did I make? Parallelogram. Agreed? That's a parallelogram. And so what's the area of a parallelogram? What's our formula for area of a parallelogram? Base times height. In this case, we see that h is the height, but the base is now from here all the way to here. So how would we describe the length of that base? For this big, long parallelogram, the base is what? Base 1 plus base 2. All right, so B1 plus B2 equals the base of the big parallelogram. Agreed? So if I want to find the area of this parallelogram, area of the big parallelogram is going to be B1, oh boy, is going to be B1 plus B2, right, that's the big base, times the height. Would you agree that that's how we could find the area of that big parallelogram? Okay, but we didn't really want to find the area of a big parallelogram. We only wanted to find the area of this, this trapezoid. So isn't that half of it? Agreed? So what we want to do to find the area of the trapezoid is going to be B1 plus B2 times h divided by 2. So that's where these formulas come from. So you're getting this written down, that the area of a triangle is half the base times the height, and the area of the trapezoid is 1/2 quantity, B1 plus B2 and quantity times h, or you could write it as B1 plus B2 in parentheses times h over 2. Do you have this formula written down? Okay, so let's take a look at an example here. So if we are things running together. If we want to find the area of a trapezoid, and B1 is 8, B2 is 5, and h is 6.2, what are we going to do to find that? Colin.
Add 8 and 5.
So you're going to add the 2 bases together, so that's 8 plus 5, and multiply it by 6.2, and divide by 2. Calculators, what do you get?
40.3.
40.3? Do people agree? And on the homework, I'm going to ask you to complete this worksheet as part of your homework. I am going to ask you to fill in appropriate units for all of these. So in this case, it would be 40.3 square inches. All right? Okay. Okay, let's. All right, let's try. Let's try this next example. In this case, we are trying to find B2 of this trapezoid in which the area is 231 square millimeters. If we want to find B2, because we already know the first base is 23, we're trying to find the other base, we know that the height is 11, and we know that the area is 231 square millimeters. All right, so I'm going to ask you to go back to the formula, which is 1/2 quantity B1 plus B2 times H. I'm going to ask you to plug in what you know and solve for what you don't know. So what are you going to plug in here, Jacob? What am I filling in?
All right. Triangle. Trying to find.
It's a trapezoid. Do we know A? Do we know B1? Do we know B2? Do we know H? What are you going to fill in?
A equals mechanics squared. If I look at the B.
We're right here.
Oh.
Yeah, we're not on that problem. We're on this problem right here.
All right. I know the area. 231.
231 equals 1/2 times, what am I filling in here? Okay, 23.
Plus squared.
And that's not a B squared, that's a B sub 2, which just means we're keeping the two bases separate. One's called B sub 1, the other's called B sub 2, or you could say B1 and B2. Times 11. Everybody agree? All right, at this point, we have the algebraic task of solving for B2. We need to get B2 by itself. So what would you recommend doing first in order to accomplish that, Nicole?
Or dividing 11.
Dividing both sides by 11. Okay, if we divide both sides by 11, what's 231 divided by 11? So I get 21 equals 1/2 times 23 plus B2. All right, what could be our next step? Anna? Divide by 0.5. All right, divide by 1/2 to both sides, or you could think of it as multiplying by 2. Multiply both sides by 2, because the 2 here will divide out with the 2 there. So I get 42 equaling 23 plus B2. So our last step in solving for B2 would be what? Stephen?
Subtract 23.
All right, subtracting 23, and we end up with what? 18, and what units are we talking about? Millimeters or square millimeters? Just millimeters, because remember, we're trying to find a side length. Length is linear. Who told me 18? Oh, I misheard. Okay.
Good job, Harry.
19 millimeters. Are we okay with this? Stop it. Be nice. Okay, let's talk about kites and rhombuses. A kite or a rhombus, first of all, we talked about both of these. Agreed? What do you know about a kite? What do you know about a rhombus? What's common to both of these? Megan? Well, the rhombus has all 4 sides congruent, and you're saying that the kite would have 2 pairs of congruent sides, but the 2 pairs of congruent sides are consecutive? Okay. And then what can you tell me about the diagonals? What was special that we learned about the diagonals when we were in our chapter on quadrilaterals? Something was special about the diagonals of both the rhombus and the kite. What was special about those? They were perpendicular to each other. So the diagonals are perpendicular in a kite and they're perpendicular in a rhombus. And as a matter of fact, it's those diagonals that give us a special way of finding the area. All right, and I'm just going to skip the long explanation here and get right to our formula for finding the area of a rhombus or a kite. It's just half of the product of the two diagonals. So if this is diagonal D1 and this is diagonal D2, then the area is going to be 1/2 of D1 times D2. Same thing for a kite. If this is D1 and this is D2, you just multiply those two diagonals together and divide by 2 and you will have your area. All right, everybody's got that formula written down. All right, so let's try this example. Find each measurement. You want to find D2, which is one of the diagonals of a kite, in which D1 is equal to 14 inches, and the area is 238 square inches. So how are we going to set this up? You can get one of those yet, Colin? Julia. So 1/2 of 14 times 2, D2 or D sub 2. Okay, so how are we going to solve this equation that Julia set up for us? Megan? All right, dividing both sides by 1/2 or multiplying both sides by 2. Either way, if I do that, then I get 2's divide out. 2 times 238 is 476. What is it? It's 476 equals what? 14 D2. So D2 turns out to equal what? 34? 34, and so D2 is 34. What units are we talking about? Inches or inches squared? What?
Inches.
Just inches, because we're talking about length. All right, and let's try this one.
Oh, I hate these ones.
This one is getting a little practice in algebra.
Oh, my God.
All right, let's do this. We're not looking for an actual number here. We're looking for an expression in terms of x. So what am I going to write down to get this expression? Lauren? Okay, a equals 1/2. All right, and so if we use FOIL on this, first, outer, inner, last, see what you come up with for this. Stephen, talk me through the foiling step here.
You go 8x times 14x.
Okay, and that gives you what? 112x squared. How about the outer terms? What's that going to be, Joe? Yeah, let's do outers.
Times -6.
Mm-hmm.
And that would be -48x.
-48x. How about those inner terms? What do we get when we multiply those, Anna? All right, so I need a plus 98x, and gotta get rid of this. It's 98x, and then what about the last terms? I'm trying. Last term's going to be what here, Amanda? Plus 42. Do people agree? 7 times negative 42. Okay, and so if we combine our like terms here, what's negative 48x plus a 98x? 50x. So I get 1/2 times 112x squared plus 50x minus 42. And if I can distribute that 1/2 through here, what will we get? 56 x squared plus minus 21. Are we okay with this? That's what we have as our answer here.
So you may have to at least solve it.
Yeah, I mean, if they said, and the area is, 112, so solve for x, then you'd have more work to do. But for right now, they were just looking for an expression. Okay, so let's try this one. Find D2 of a rhombus in which D1 is 3x meters and the area is 12xy square meters. So we're looking at a rhombus. Here's our rhombus. All 4 sides are equal. I'm drawing in the diagonals. I know that this diagonal, for example, is 3x. And I don't know the other diagonal, but I know that the area of the whole thing is 12xy. So how are we going to find an expression for this diagonal here? That's what we're trying to find. What's our formula for the area of a rhombus, Aaron?
A equals 1/2 D1 plus D2.
1/2 D1 times D2. Okay, and then what? We're going to plug in what we know. What do we know in this case? What can we plug in? Go ahead.
The area is 12xy.
All right, so I'm going to say 12xy equals, then what? 1/2 3x, and we don't know what D2 is. So what are we going to do to find D2? Julia? Multiply both sides by 2. Get rid of that 1/2. So I get 24xy equals, those are dividing out, 3x times D2. What's our last step in solving for D2, Megan? We want to get D2 by itself. Divide by 3x to both sides. Now the 3x's divide out, and we're left with D2 equaling, let's see, does 3 go into 3 once and 24 8 times? Does the x here divide out with the x here? So what are we left with? 8y as our other diagonal. And it would be 8y, what units are we talking about? Meters. All right. All right, I'm going to skip this. Okay, so at this point, I want you to take a look at your worksheet. And I'm going to stop this recording.